This podcast has to do with graphing, all right? And essentially, there's two main types of graphs I want you to be familiar with in chemistry. So first off, we're just going to draw kind of a little graph line over here so that we can plot some points. And then our first scenario is going to be, let's say we go to have pizza, all right? And we're going to get a large pizza that has 12 slices. All right, so if you're the only person eating the pizza, how many slices can you have? So if we say one person, so if you're the only person, you can eat all 12 slices. Hopefully not at once, but all 12 slices. So if we plot people versus slices, we might say here's 1, and up here is going to be 12. So we're going to plot a point. Okay? The next scenario might be, maybe you're going out with a friend. Okay? So there are now 2 people. And if there are 2 people, how many slices can you each have? You can each have 6 slices. Alright, so if this is 1, here's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, and up here, let's see if it works out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so if there's 2 people, we can each have 6 slices. So we're going to put a point right there. Alright, if there's 3 people, okay, so you find somebody hanging out, and you invite them to have some pizza with you, we can have 4 slices apiece. So 3 people can have 4 slices, and we're just going to keep on going. 4 can have 3 slices, 6 people can each have 2 slices, and then this would be just a tragedy if you had 12 people. You would each only get 1 slice. Okay, so let's plot these. So 4 people could have 3 slices, 6 people could have 2 slices, and 1 person, or 12 people, could have 1 slice. Alright, so if we connect our dots, let's see if I can do this, we kind of get a graph that looks like this. Okay? We're going to come back to that in a second. So our second graph, because we're talking about food, we'll keep on talking about food, but our second graph is going to be, let's say our second graph has to do with, you have a lemonade stand, okay? And you're going to sell lemonade for, let's say, 75 cents a cup, and you're going to profit 50 cents for every cup you sell, okay? So if you sell 1 cup, right, you are going to make 50 cents. Alright, and we're just going to plot cups versus money this time. Alright, so we're going to put some cups in here. Let's say 1, 2, 3, 4, 5, 6, 7 cups. That's a terrible. I'll do our 1, 2, 3, 4, 5, 6, 7. Alright, we're going to ignore this one. And then as far as money goes, we might say 50 cents. Here's $1. It's $1.50. Here's $2 and $3. Alright, and money's going to be measured in dollars. Alright, so 1 cup's 50 cents. So if we sell a cup, we're going to make 50 cents profit. If we sell 2 cups, alright, we're going to make $1 profit. There we go. So for every 2 cups we sell, we're going to make $1, so we're going to plot that point right here. Let's say we sell 4 cups. We're going to just skip some, speed this up a little bit. If we sell 4 cups, we can make $2. And if we sell 6 cups, we can make $3. Alright, so we're going to plot these points. So 4 cups is $2, and 6 cups is $3. Alright, and now we're going to connect these lines and get another graph. Alright, so we have 2 distinct graphs. One of them looks a straight line on the bottom, and the other one is kind of like an open-faced parabola. Alright, so really what we want to look at is, how do the numbers correspond to the shape of our graph? Alright? So, as we look at these numbers, what happens to our people? They keep on getting bigger, and as people get larger, what happens to our slices? They get smaller. So as one gets bigger, the other one gets smaller. And what that's known as is an inverse relationship. Alright? Possibly in math, you might also call it an indirect relationship. but inverse or indirect. As one goes up, the other one goes down. Conversely, down here, if we look at our cups and our money, as we sell more cups, what happens? We make more money. All right. So our example down here is a direct relationship. Okay. So notice that inverse or indirect relationships end up in this open-faced parabola. All right. Whereas direct relationships end up in a straight line. All right. So the other thing I want to look at is how if we just look at the numbers, how might we come up with where these numbers come from? So in our top instance, how did we know that 2 people could have 6 slices? Okay. Well, if we know we have 12 slices to start off with, and we have 2 people, we can divide that. Okay. But also look at the fact that if we take 1 times 12, we get 12. What is 2 times 6? It is 12. What's 3 times 4? It is 12. What's 4 times 3? It is 12. What's 6 times 2? 12. 12 times 1 is 12. So our variables, if we multiply our variables together, we get some kind of constant. So up here we might just say A times B gives us some constant. We're just going to call it K. All right? Now we're just going to put constant in parentheses. All right? So let's contrast that with our cups and our price. So if we multiply 1 cup times 50 cents, we get 50 cents. What if we take 2 cups times $1? We get $2. 4 cups times $2, we get 8, and 6 times 3, we get 18. So we're not getting a constant. So is there something else? Kind of from math, you should know if we have a straight line, that is a constant. Okay, the slope is a constant. So how do we calculate slope? Slope is usually rise over run. Okay, so if we look at this, our rise is related to our money, and our run is our cups. Okay, so let's take 50 cents divided by 1. We would get 50, okay, or half, because 50 cents is half of $1. So half divided by 1 is half. What is 1 divided by 2? Oh, that's a half as well. What's 2 divided by 4? That's a half as well. What's 3 divided by 6? That's a half as well. So in this instance, we don't want to multiply A times B, but if we take A divided by B, we also get a constant, which is K. Alright? So, kind of 3 things we can talk about in terms of graphing. Graphs can be inverse or direct. They can also be exponential, but that doesn't really work that well in chemistry. So inverse or direct. An indirect relationship, where inverse looks like a parabola, a direct looks like a straight line. And if it's inverse or indirect, if we take our 2 variables and multiply them, we get a constant. In a direct, if we divide our variables, we get a constant. Okay? And that sets us up for the gas laws we'll be looking at.